Problem number 3.6. A bullet having a mass of 0.05 kilogram is moving with a speed of 100 meters per second. It penetrates into a bag of sand and is brought to rest after moving 25 centimeters into the bag. Find the deceleration force on the bullet. Also calculate the time in which it is brought to rest. So in this problem, we have to find the force on the bullet, which is going to stop the bullet when it penetrates into the sand. Let us see the animation. So here is this bullet that is going to hit the bag and penetrates into this bag of sand. Let us suppose the initial velocity of the bullet is vi when it hits the bag. When it penetrates into the sand, its velocity will decrease slowly and finally the bullet stops inside the sand after covering a distance s. This is the initial point and this is the final point. And this is known as the distance s. We have to find this distance s and the time taken to cover this distance. Here is the initial velocity, which is 100 meters per second, and when it finally stops inside the sand, its final velocity vf becomes 0. So we will use this data to find the force on the bullet from the sand and the time taken to cover this distance. So let us calculate. Here is the techniques to solve any numerical. First of all, we have to write down the data from the problem, and then we have to convert any data into SI units. After that, we will write down the equation. Then we will use this data in the equation and calculate for unknown parameters. Finally, we will write down our answer in SI unit. So let us write down the data from this problem. So mass of the bullet MB is 0.005 kilogram. The velocity of bullet, which is we call initial velocity, which is 100 meters per second. Distance covered by this bullet is 25 centimeters. So we will convert this 25 centimeter into meter. So this will become 0.25 meter. And we know that final velocity is 0 when bullet is stopped inside the sand. So we have to find the force on this bullet and the time taken to cover this distance. We will apply Newton's second law. So according to Newton's second law of motion, the force on the bullet is given by F equal to mba, where mb is the mass of bullet and a is the acceleration, which should be negative because this is a negative acceleration on the bullet. So first of all, we will calculate this acceleration from this equation. 2as equal to vf square minus vi square. So we will use this data 2a 0.05, which is equal to 0 square minus 100 square. So if you solve this, you will get 0.5a equal to minus 10,000 because the square of 100 is 10,000. Rearranging this, we will get acceleration is equal to minus 10,000 divided by 0.5, which is equal to minus 20,000 meter per second square. So now we will use this acceleration into this equation F equal to ma. So F equal to mba is equal to the mass of bullet is 0.005 multiplied by acceleration, and if we multiply, we will get minus 100. So here minus means negative force or deceleration force. So deceleration force will be 100 Newton. So this is the answer of our problem. Now we will calculate the time. For time we will use this equation, Vf equal to Vi plus At. Here the final velocity is 0 and initial velocity is 100 and acceleration is minus 20,000, and from this equation we will find 20,000 is equal to 100 Newton because minus will become plus, and after rearranging we will get T equal to 100 divided by 20,000, which is equal to 0.005. So time is 0.005 second. This is the answer.